Hey, this is lesson 3.1. So, welcome to chapter 3. Starts on page 82 in your textbook. And we're talking about combining like terms. So, parts of an algebraic expression are called terms. Like terms are terms that have the same variable raised to the same exponent. So, we're not going to be raising them to exponents, at least not this early in the year, but we will be having different variables. So, terms that have the same variable are called like terms. Constant terms are also like terms. Remember, constants are terms with no variable. To identify terms and like terms in an expression, first, write the expression as a sum of its terms. So, for instance, identifying terms and like terms here, here is an expression. And they want you to rewrite that as a sum of the terms. So, instead of putting 9x minus 2 plus 7 minus x, they put 9x plus a negative 2 plus 7 plus negative x. That's the same thing we were doing earlier when we were combining terms, where we just look at this as a 9x, a negative 2, positive 7, negative 1x, just like that. If you'd like to rewrite them out like this, that's fine. But I just go through and circle them like that. It's the same thing. Now we're combining, or we just identify each of these terms. So what are the terms? 9x, negative 2, positive 7, negative 1x, or just negative x. If it's a coefficient of 1, you don't need to put it, but you do need to understand that it's there. Like terms would be 9x, negative 1x. Because they have the same variable. So they're like terms. And negative 2 and positive 7. Those are like terms because they are constant terms. Over here, we've got z squared, positive 5z, negative 3z squared, positive z. So what are the terms? Well, just like I said, z squared, 5z, negative 3z squared, and z. What are the like terms? So they're giving us an example with different exponents here. We won't be doing that throughout the chapter though. But z squared and negative 3z squared are like terms because they're both z squared terms. 5z and z are both like terms because they're both z terms. An algebraic expression is in simplest form when it has no like terms and no parentheses. To combine like terms, here's what we do. We put them together. We just combine them, just like we were combining integers way back at the beginning of the beginning of the school year. It's the same thing we do here. So let's look at their example right here. We want to simplify this expression right here. So first, let's look at what the terms are. We've got 3/4 y, 12, negative 1/2 y, negative 6. Okay, so there are our terms. We combine like terms. 3/4 y minus 1/2 y. Well, we would need to have a common denominator, so 3/4 y minus, we'll call this 2/4 y. 3/4 y minus 2/4 y is 1/4 y. Positive 12 and negative 6, different signs, subtract, keep the sign of the larger number, so it's just going to be positive 6. So when I combine the like terms, I have 1/4 y plus 6. All right, here are some that we can try, you can try on your own. Okay, we also need to simplify an algebraic expression sometimes by using the distributive property. Hopefully you remember from last year, and if you don't, no big deal, I guess. But when there's something right outside the parentheses here, in this case a negative 1/2, that means that that negative 1/2 is multiplied to each thing inside the parentheses. So this negative 1/2 is multiplied by 6n, and the negative 1/2 is multiplied by the 4. It's called the distributive property because we're distributing this value to each term inside the parentheses. I do not distribute it to the 2n because the 2n is not in the parentheses that this is touching. Okay, so let's look at what that looks like. Negative 1/2 times the quantity of 6n plus 4. I can't add those because they're unlike terms, so they just stay like that. Plus 2n. Well, that would equal negative 1/2 times 6n, right there, plus, because there's a plus right there, negative 1/2 times 4, which they showed right here, negative 1/2 times 4, plus 2n, which just comes along. It's not multiplied by anything. Well, now we can actually do the multiplication. Negative 1/2 of 6 times 6n is the same as 1/2 of 6n. Of means multiply in math. 1/2 of 6n would be 3n. So half of 6 is 3. So different signs, so it's going to be negative 3n when you multiply those. Plus, and then I have negative 1/2 times 4, or 1/2 of 4. Well, half of 4 is 2, of course. So it's going to be negative because there's one of each. When we multiply, different sign, negative. So negative 2, and then plus 2n. Still just coming along for the ride, hasn't really done anything yet. But we can't drop it. Now, we switch these around. You can skip this step if you can just do that in your head, but they switched it around because they're just addition. We switch these two terms like this. So these two are next to each other, and we can combine them. And we know that negative 3n plus 2n would be, when we combine these, negative 3 plus 2, different signs, so we subtract to get 1, and we keep it negative because the negative had the larger absolute value. So these two combine to be negative 1n plus a negative 2 still. When we write that, negative 1n, we just write as negative n, because when it's a coefficient of 1, we can leave the 1 off. It's just understood to be 1. So negative n, if you want to put negative 1n, that makes you feel better, go ahead. And then instead of plus a negative 2, we just put minus 2. So we have a negative n and a negative 2. We can't simplify anymore because they're not like terms. Here are 3 to do on your own. Okay, for number 7, the first thing we need to do is get rid of this distributive property here. So remember, this means 3 times the q and 3 times the 1. So we'll do that right away. 3 times q is 3q plus 3 times 1 is 3. And now this minus 4 comes along. There are no other q terms here, so I can't combine 3q with anything, but I do have 2 constant terms. I have a positive 3 and a negative 4. Different signs, so I subtract to get 1. And I keep it negative because the negative had the larger absolute value. So 3q minus 1 is the answer. For number 8, distributive property, negative 2 times g is negative 2g plus negative 2 times 4 is negative 8, different sign, so negative, plus 7g just comes along for the ride. I've got negative 2g and positive 7g. Different sign, subtract. Keep the sign of the larger, this time it's positive, so 5g, and then this plus negative 8. I don't have any constant terms to combine with this one, so I could put plus a negative 8, but that's not as simple as just putting the negative 8, or minus 8. 5g minus 8. And finally, 7 minus 4 times this quantity here. Well, what am I distributing? I'm distributing this negative 4. I have a 7 and I have a negative 4. So this negative 4, so this 7 goes here. Negative 4 times 3/4 x. Okay, so negative 4 times 3/4 x. And if you don't remember how to multiply a whole number by a fraction, you could turn the whole number into a fraction times the fraction itself. So 4 is really 4 over 1 times 3/4. And when you do that, simplify before you multiply, you're just going to end up with 3. Okay? So negative 4 times 3/4, different signs. So negative what? Negative 3. Not just negative 3, but negative 3x. Don't drop the variable. Negative 4 times a negative 1/4. Well, now I have a negative times a negative, so I'm going to have a positive. And 4 times 1/4 is just 1. And you can go through this similar process over here to figure that out if you didn't know that. 4 times 1/4 is 1. Negative times a negative is a positive. Well, now I can combine like terms. I have a 7, a negative 3x, and a 1. Well, the 7 and the 1 are both constant terms. I'll combine those, and I could make it 8, and then I've got the negative 3x. I like to put the variable term first, so I would take the negative 3x and put it out front and have it followed by the positive 8. So it would look like this: negative 3x plus 8. A lot of students, when they turn this around, get 3x minus 8 just by switching these two numbers or two terms. You can't do that. This is a negative 3x, so when you pull it out front, it's still a negative 3x. This is a positive 8. When you put it behind, it's still a positive 8. So negative 3x plus 8.